Hello everyone, today we're going to be learning a little bit about the properties of metals. So we've got a couple goals for today. We want to understand which elements on the periodic table are metals versus which ones are non-metals. We're going to learn about the properties of metals, how they are conductive, malleable, ductile, how they have high melting points and how they tend to form cations. And lastly, we want to understand part of what gives metals these particular properties, how they can form metallic bonds, and what it means to have an electron C. So the first thing I want to make sure you understand is that most elements are actually metals. Everything you see here in color, all of those are metals. That means most of these first two columns, with the exception of hydrogen. It means this whole middle block, both of these whole big bottom blocks, and even a couple elements on the right-hand side of the periodic table. There's really only actually a few elements that are non-metals. We've got the noble gases, they're not metal. We've got what are called the reactive nonmetals, which is like carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. There's a little section here. And then there's a couple that are sort of in between being metals and nonmetals. We call those metalloids, and we'll talk about them later. There's also this section here that you might notice, elements 109 through 118. What's going on with those is they're man-made. They only exist in laboratories and only for really brief periods of time. So we haven't really been able to have enough of those created for us to actually look at the properties of those elements and determine if they're metals or if they're non-metals. So most of the periodic table is actually metals, and that means if you learn the properties of metals, you'll know a lot about many of these elements and how they behave. So metals are conductive. That means they conduct both electricity and heat. They are malleable, which means that they bend or dent under pressure. So say if you hit them with a hammer. They are ductile, which means you can make wires out of them. They have high melting points, which means they tend to be solid at room temperature. And they tend to form cations, which, as you will recall, are positive. So the first of these properties is that metals are malleable. So to be malleable means that if you hit it hard, it's going to bend instead of breaking. Take a moment and imagine a glass, like a drinking glass. If you set that glass on the ground, you take a hammer and you thwack that glass with a hammer, it is going to shatter into a whole bunch of little pieces. That's because glass is made of silicon, and silicon is brittle. Most metals aren't like that. If you take a hunk of iron and you set it on the ground and you hit it really hard with a hammer, it's going to dent instead of shattering. And if you hit it hard enough, you could actually hammer it out into a thin, flat sheet. So that property is called being malleable, when you bend instead of breaking, when you can easily be flattened out into thin sheets. And that's not the only shape that you can easily turn metals into. So the next property of metals is that metals tend to be ductile, which means they can be drawn out into thin wires. So, for example, most of the wiring inside your house that's carrying electricity around is probably copper wire. And because copper is a metal, it's Cu, right, is the element symbol. It is number 29 on your periodic table in this middle section. Lots of metals in that middle section. So you got Cu, copper right there. It's a metal. It is ductile. You can easily make wires out of it. And we tend to use copper for lots of our wiring in our homes. And the reason why we might want these wires is because metals are conductive. They conduct both electricity and heat. So for our purposes, we're going to care a lot about the ways in which metals can conduct electricity. So these are some examples of projects that students have made in my class. You can see on the right-hand side, there is actually a battery in one of these projects. So right here is actually a battery. And you have all this copper tape, which of course copper is a metal. Metals are conductive. And that copper tape is actually creating a pathway to move electrons from one side of the battery to the other side of the battery. So as those electrons are flowing, they're moving through these lights and allowing us to use that electricity to harness it to do something useful. So metals are conductive. Electricity can easily move through any sort of metal. And that allows us to use them to create all sorts of interesting projects. The other thing that being conductive can mean is that metals actually also conduct heat. So metals conduct heat very easily. Imagine you've got a boiling pot of water on your stove, or like a boiling pot of soup or something. And you have two spoons. One spoon is made of wood, and the other spoon is made of metal. If you stick both those spoons into your pot, what you're going to notice is that the wooden spoon doesn't really heat up much, at least not the handle. But the metal spoon is going to get really hot really quick. So the reason why is because wood is made out of carbon, hydrogen, and oxygen mostly. Probably a little bit of nitrogen and phosphorus in there too. Those are all nonmetals, and it's just not very conductive. It doesn't transfer heat well. But the metal spoon is going to easily transfer heat from your boiling soup up to your hand. So metals can easily conduct both heat and electricity. Next thing you should know about metals is they tend to have pretty high melting points. So as a result of this, it means that metals are most likely going to be a solid at room temperature. So most metals will be a solid at room temperature, and you have to get them really, really hot, for example, in a forge, in order to get them to melt. So usually it takes pretty high temperatures to melt most metals. Now, of course, as with anything I tell you in this class, there are going to be exceptions. So, for example, mercury, which has the symbol Hg, it is element number 80 on your periodic table. It is right here, Hg, mercury. Mercury is actually a liquid at room temperature. So at room temperature, mercury is a liquid. It will create this, sort of this beautiful silvery liquid, super toxic, so definitely don't play with mercury. Gallium, which is another metal, it is element number 31. Its symbol is Ga. So it is right here on your periodic table, gallium, Ga. Gallium actually melts pretty much at human body temperature. So if you have like a gallium crystal and you put it in your hand, it'll actually melt in your hand, which is pretty weird. So gallium melts at body temperature. Solder, which is a metal that we're going to be using in our class, is made of either tin or lead. There's different ways to make it. And both of these are metals that have relatively low melting points, by which I mean a couple 100 degrees Fahrenheit. So temperatures that we can use some simple tools in our classroom, like a soldering iron or a soldering iron, to heat up to a couple 100 degrees. And we can use that to melt solder. So this is basically like a wire made out of either tin or lead. That's what you can see here in this image. And we can actually use it to create a sort of molten glue to connect electrical components like lights down onto copper. You will never actually be able to get a soldering iron hot enough to melt copper, but you can get it hot enough to melt solder with relative ease. So, next property of metals is they tend to form cations. Remember, cations are positive. So what this means is that you can have a metal, which tends to form cations, and if you combine it with a nonmetal, which tends to form anions, you can usually create an ionic bond. So most ionic compounds are made out of a metal and a nonmetal. And then the last thing I want to cover is why the heck metal has these properties. And it has to do with what those valence electrons are doing. So remember, anytime we're talking about bonding, we are talking about what those valence electrons are doing. In an ionic bond, one atom gains electron, another atom loses electrons, they become tiny magnets and are pulled together. In a covalent bond, it's about atoms sharing electrons together. And you might have like two atoms sharing an electron. In metallic bonds, it's a little bit more extreme than that. Metals have this amazing property where basically you can have, millions upon millions of atoms of a metal, and they will just all share electrons. Individual electrons won't belong to any one atom. They kind of belong to everything, and it's just communal property, these electrons. This is called the electron sea. And when you have a hunk of metal, you could say it's held together by what are called metallic bonds. And what this does is it basically allows just a hunk of metal on its own to be stable. So you would never run into, say, a lone oxygen atom in nature, because a lone oxygen atom, it's just not going to be stable. It's going to want to bond with something. But you could have a hunk of sodium or a hunk of potassium or a hunk of iron. That can totally exist in nature because metallic bonds make it possible for this to be stable on its own, because kind of just everyone shares all the electrons. All right, so today we learned about metals on the periodic table and the fact that most of the periodic table is actually made of metals. We learned that metals are conductive. They conduct electricity and heat. We learned that they are ductile. They can be drawn into wires. We learned that they are malleable, which means you can hammer them out into sheets. They bend instead of breaking. We learned they tend to have high melting points and are usually solid at room temperature. And they usually form cations. And lastly, we talked a little bit about this concept of metallic bonds and the electron sea. That concept of the electron sea is actually why metals have some of these properties. Like the reason why a metal can be conductive, why it conducts electricity, is because if all of the electrons are shared from atom to atom, if you put in extra electrons at one side, they're just going to keep being passed along through the atoms as you go. So it is the properties of metals that make them so useful, and you'll have a chance soon to play with these in a project.